All right, here we are over at the Grizzly Geo509G gunsmithing lathe. We have the Cheska Zbrojovka 457 installed in the blueprinting jig. The jig is installed in a very heavy, beefy 4-jaw chuck. The jig has been roughly centered, well, the jig has been centered, and now we are just going to roughly center in the actual action within the jig. So in other words, the jig is centered to the chuck. Now we're going to center the receiver to the jig and get this thing running axially and radially aligned to the center line of the bolt bore raceway. So as I spin this chuck, hopefully you can see we're close, but certainly not even close to perfect alignment. So you can see this jig has 2 sets of 4 set screws. And it's a lot like a 4-jaw chuck in the way that it can center an object. So a 4-jaw chuck can center an object radially, meaning centering apart so that it spins true and round. This is an 8-jaw chuck essentially, so this gives us the ability to center it radially, the same way a 4-jaw chuck would, but also axially, so that any axial runout can be completely taken out of the part that we're trying to machine, in this case a 22 rimfire receiver. So in this manner we can get this thing running straight and true in order to clean up this face, to take out and eliminate any run out or offset from the machining process in the manufacturing of this receiver. So that will ensure that the face of this is running true, and then when we cut the threads, those threads will be perfectly straight and true to the bolt bore raceway center line, datum line that we're establishing here. So we're going to probably fast forward through a little bit of this. But I just wanted to show the initial setup, and we're going to get this just roughed in generally. What we got here is a dial test indicator on a Noga stand that is touching off on 2 parts. We're going to be centering here and then aligning here. So you can see there's a high spot as the dial goes to the right. That means the bar is actually pushing the indicator probe up, saying that at this position, at this point in the radial rotation, that's high, and then low, obviously, and we're all the way off. So if I take these 2 screws, that's going to affect the adjustment here, as you can see. So as we rotate around, we want to just kind of adjust things, and we're going to have to retouch off on that a little bit. So there's low, high, high, low, high. So we're just trying to get this portion of it running radially centered, true. And we got to go back and forth and back and forth. So you see we're real close now, a couple thousandths. So each little line on this dial test indicator is 1/2 of a thousandth of an inch. So now the front end of this is essentially running very close to true. But as we go back, we can see our axial alignment is way out of alignment. Let's just adjust that. And so now this is going to be the opposite. When we push down on the action, that's going to raise up the back end and lower. So if we screw the screw down and this one out, that's going to raise it up. So we're looking for the low spot on this particular. So there's high, high again, way high, and then low. So we're going to the low spot and do an adjustment. So there's high, low, and now we're fairly close. So we've got to go back and forth until this is running as perfectly true and round and axially aligned as we could possibly get it. So we're going to come back and you'll see that this one affects the other. So this one will be out again. Not as bad as it was, but it's going to shift it out. So we'll get this as close as we can with our 1/2 thousandths. See a simple adjustment there. Come back and do the back end. Get this thing running close, and then we're going to switch over to a 1/10,000 style test indicator. And that's going to get us as close as we can possibly measure to within 1/10,000ths of an inch, radially and axially aligned in the lathe before we do any cutting. Exactly like a center fire bolt action. Same exact process. Same attention to detail, precision high-end service that you're going to get here at Accurate Rifles and Restorations. Okay, I think that's close enough for now. Yeah, we'll switch up, move over to the 1/10,000ths, dual indicator setup, get this thing running as true as we can, and then we'll do a few measurements. We'll take a measurement off the face, see how far that is off in terms of run out and all that good stuff. So we'll be back for that. Now I have two 1/10,000ths dial test indicators installed. So one is this Meditoyo up front is obviously touching up here on the front, and then the Poopy Tost is reading the back end. This will just show you, it's a little easier to show you both at once. I can do like I did before, but anyway, this shows you both at once, kind of how one affects the other and how we'll get this running perfectly true to within 1/10,000th of an inch, as I'm saying. So just to show you, if I physically push this bar, you can see high and low and how it doesn't take a whole lot to make that move. Up front, it's more rigid, so that's not going to move so much. But you can see the needle move as the chuck spins. So same thing, we'll just choose this front one, and we'll go to the high side, make a slight adjustment, and you can see how that affects the back. So now the front end is running much closer. Now the back end's a little bit further off. So vice versa. The back end, we're going to look for the low spot and make an adjustment. And there you can see we're super close now. At this point, I'm going to switch over to a wrench because we want to start snugging things up a little bit. This will allow me to start closing in on things, get things tight, so we certainly don't want anything to shift as we're machining them. So I'm going to go to the high side on this one, crank it in just a slight, and then the low side on the back one, make an adjustment. So we're still very loose on the set screws. We're just going to go back and forth. Okay, so the front one's almost there. And I say back even though this is in the front, this is actually metering the adjustments on the back set screw. So that's why I'm referring to this as the back and this is the front. So we're looking for low on the back, tighten the low. Within about 2 or 3 there, tighten the low. We're within, well, quite a bit there. See, the back end is still relatively loose. Front end's starting to snug up pretty good. So now I made an adjustment on the front, which affects the back. So you see the front is relatively barely even moving anymore. Back one could still use a little love. We're within about 2/10,000 here. I can feel that the screws are getting snugger, more tight, as it were. And so we are almost dead nuts right here. So now I'm just going to go around to each screw and just gently tighten because now I want to make sure we're tight. I don't want to be so tight that I'm crushing anything in terms of the internal bore, but there's kind of a trade-off. You need to be tight enough so that nothing shifts because once we start machining things, We can come back and double check and set this all back up, but I've got to scoot that bushing away in order to get inside there to cut the threads and all that stuff. So I just want to make sure everything's tight enough that we're going to be rigid for machining and also not slip and not be so tight that we're crushing things, essentially. So you can see I'm not using the back end, I'm not wrenching on this thing, I'm using finger kind of pressure on the very front. In fact, I could even use, you know, just this kind of stuff, but it's experience. I've done hundreds of center fires in the same way, so it's a matter of feel, really. So now I'm going to work on that back one a little bit. Right, so here we go. I'm going to do a little bit of fine tuning, but you can see now we are running really good, really true. So let's just make sure. Let's change the. I just want to make sure we're not bottomed out on anything here. So the number where the needle is and the number doesn't matter at all. We're just making sure that needle doesn't move, essentially like that. We don't want to see any run out. So you can see no matter where that needle is in the rotation of the dial, even though we're on 5, it doesn't mean anything really. All we're trying to look at is actual run out. And same with this back one. So you can see just by touching it how sensitive that is. You know, so we're zero. We're not moving here. We're not moving here. You know, maybe just a touch. So I'm just going to go around all 8, making sure it feels snug, making sure nothing's moving. Now this 457 receiver has flats on it, which is really a benefit, that it gives us more surface area to bear upon, so less chance of anything slipping out on us, which is great. We want to be nice and rigid, just like any machining operation. Take our indicators off, because I got to slide this bar out now without bumping anything, and luckily, see how loose it is? Not loose, but we're not crushing anything here. So guys, like if I were crushing this too tight, this bar would be essentially viced in there and we wouldn't be able to get it out. But now I just want to pull it out as gently as possible. I don't want to bump anything. I don't want to move or change anything at this point. Now the machining is going to have a lot more force on this than my hands here, but at the same time I just do not want to bump anything here. Just very carefully remove this rod. I'm going to set this aside. Okay, now I'm going to push this bushing in just enough so I can get my dial test indicator in there. Right, so let's just move this one out of the way. And then see if we can get in here. Yeah, we're still in frame on that, so let's just change this just a touch. Now I'm going to check the face first. Let's just load up the indicator. Just enough to get a reading. And yeah, this is actually very straight. We're a 0.5 thousandths. Got about a 0.5 thousandths run out on this, which is actually pretty impressive. That's a lot flatter than most bolt actions that I work, or center fire bolt actions that I work with. So that's surprisingly good. We're still going to skim past it just to straighten things out, but I mean that's impressive for a factory-produced, mass-produced receiver. That is dang close. So that's impressive. So let's check the actual inside surface as well while we're here. So let's change this needle just a touch and bring it in. Hopefully we're still in focus. Touch off. Have to bring it, oops, a little bit down this way. Okay, same thing. So, wow. Just a same thing, about 4/10, half thousandths. We'll call it a half thousandths at the most. So that's nice. That actually means I don't even have to bore this out. I don't have to do any boring, pre-boring, or any truing up. Primarily because the major diameter I'm shooting for, this is already right at the minor diameter. Not to get too technical here, but I can just, well, all this is telling me is if it were way out, if we're talking a couple even a thousandths of an inch run out in there, I would have to go in there with a boring bar and true up that surface before doing any thread cutting. But in this case, we can just go right to the thread cutting, so that's great. Okay, so I'm happy with this. Pleased with the results I'm seeing. Congratulations, Česká Zbrojovka. You make some really good stuff here, as proven on camera here. So I'd say about 4/10 run out on each surface, which is amazing. That's really impressive. So I keep blabbering on about the same thing. Let's cut it here. Let's get some tooling in the machine, get everything on, powered up, warmed up, and let's get ready to cut this action and true it up and get those threads in there for the new barrel. All right, we are all set up and ready to go. We're gonna face this off just enough, take a few thousandths off, whatever, probably don't even, hopefully just 1/1000ths, honestly. We don't need a whole lot. As you can see, the run out was less than 1/1000th of an inch. So we're just gonna take as minimal amount as possible. And this won't take long, so we've got I'm going to use high-speed steel in this. Don't think I need carbide. If it seems like it's unhappy, then we can switch out to a carbide cutter. But for now, I'm just going to zero out both of my AROs. So we've got a travel indicator here and my hand wheel. Just zero that out just for a double reference. We're going to turn the machine on and feed out towards me, so that we're not pushing a burr into the section of the receiver that we were going to cut the threads into. So, like I said, at this point, we're just going to go ahead and clean this up, clean up that little file mark that I made, testing out the hardness of the steel. And so yeah, we'll kick this on and do it. Let's do it. And just floating above it. Positive 2/1000ths just to see if we're doing anything yet. Check, check. All right, let's go into it. Right, just a hair above zero. We're going to engage our power feed. And so we're just scraping that coating. You can see it made it shiny. So let's just stop it and observe and see what we got here. As you can see, it's not a total cleanup yet. So we basically just scraped off that coating. We didn't really lift a chip so much. Okay, so yeah, let's hit it at another 1/1000ths. Come in there, and then we're going to lock the carriage down. This is locked. There, we're lifting a chip. And yeah, this looks like cast iron. Looks like we're trued up there. So yep, we lifted a chip, and it's got very good characteristics of being cast. Kind of sprays chips, like instead of a curly chip, you just kind of get powder. I'll take another cut just to hopefully clean up this file mark a little more. I just biffed the outer edge of it, so it's not going to affect anything. It's just cosmetic really at this point. So we'll have to unlock, advance in 1 more 1/1000ths. Yep. Great. So that should be all we need. There's really no reason to take more. So this operation is done. I'm going to have to switch up to the threading. So I've got an internal threader that we're going to install next and cut those threads. Okay, now we're going to go in there. Before we do the threads, we're going to get in there and cut what's called a relief cut. Basically, we're going to cut to the major diameter right here in the front of the action, or the front of the receiver, right here, about 100 thousandths in. Now that's just going to give us what's literally called a relief cut. Two things: it's going to prevent any binding or interference from the shoulder of the barrel to the face of the receiver when it torques up, so there'll be no material there to interfere. And secondly, it'll show us as we're approaching our what's called a minor diameter in threading and machining. As the tool skims that larger surface, we know that the threads are primarily or pretty much finished. They're already cut to depth at that point, so we can stop. We've got a few stub gauges to check with, but at least visually we'll have a target to kind of shoot for, as it were. So for now, we're just going to take this carbide boring bar and zero off the face of the receiver gently. And then we're just going to cut about 100 thousandths depth into the receiver there to provide a relief. So we're putting the relief into the receiver rather than on the barrel for a few reasons. It is a 22 caliber bore, but I like to avoid putting any relief on the barrel if at all possible, just to preserve the integrity of the steel. Because if you start cutting a little too deep, I mean, this is more in the case of like a 338 cal or larger barrel, but regardless, like I said, it just provides a few benefits. It doesn't hurt anything, so we're going to go ahead and do that. Double check. Okay. We'll kick it on, touch off, and just cut to our major diameter. There we go. Yeah, it's machining beautifully. There's nothing here hard. Yeah, that's great. Real nice surface finish on that. Pretty sure you can see it. Let's take a measurement here. We've only taken about 20 thousandths, but better to measure early. Check early. Yep, about halfway there, so. We need about another 30 thousandths and we'll be there. Okay, I'll double check that measurement, but at this point we can switch over to our threading tool and proceed to begin cutting those threads. Tools installed, centered up, machine is set for the TPI that we're going for. Everything is set, we're ready to cut these threads. So let's kick the machine on and get to work. Okay, there's our initial pass. Just going to verify that thread pitch, make sure it's what I'm actually trying to achieve. It's a little tricky to see this inside, but yes, that looks perfect. We've got a nice even scratch pass there. So we are ready to continue on here. We're just going to thread until we reach our minor diameter. And yeah, everything so far so good. my cutter holder is quite large, so I've got to make sure not to. I only have a very little clearance for this tool holder. They got to be tricky. That's why I keep watching it. Advance in, take a cut. We've got a bit of an interrupted cut. There's a lot of holes in this receiver. It is what it is. But that's why you may hear like a as it goes through. It's encountering a lot of interruptions. But it's a very fine thread, so it's not very deep, luckily. Okay. Zero. Advance the tool. Take another pass. Yep. Okay, everything's looking great. Let's get those chips out of there. Get a little cutting oil. Let's use some heavy Viper's venom for this stuff. Heavy sulfur-based cutting oil. Just help everything as it cuts. Back the tool off. Enter in here. 0, 0. Advance the tool. There we go. Everything's looking good, so we're just going to repeat until we get to depth, which is we're almost halfway there. This won't take long. Zero, 0. Advance the tool. Cut. Okay, let's stop and just check our progress real quick. We're getting some nice curly chips there. So it's machining beautifully. The only thing we're battling is that interrupted cut, but it's not too terribly severe. Yeah, threads are looking good. And this is a partial profile thread cutter. We're not even going to get to that far down, but if you're wondering, I am using a partial profile carbide cutter for this. Okay, let's keep going. Take out the backlash, and then make sure we're spinning in the right direction. 0, advance the tool, engage. Let's get some more oil in there. Make sure we're still rolling there. Yep, looking good. I want to get oil all the way back. And I want the tool dwelling on, I want it dwelling on a puddle of oil inside there. Okay, 0, take it back, take out the backlash. Come on in. 0, 0, advance the tool, and take a cut. Looking good. Oh yeah. We haven't quite hit our minor diameters, but we are very, very close. Things are looking great. Nice, bright, shiny, chatter-free threads. It's hard to say. Some fresh oil in there. Backed out, gently come in, 0, 0, 0. This should be our final pass. Yep, we just skimmed our minor. So now's a good time to stop the machine and check. Let's just check. Let's check with our stub gauge. Yeah, that's looking great. Let's check with our stub. We're there. Look at that, guys. This is a calibrated go gauge. All the way in. We are cut to depth. Threads look great. So I'm going to stop there. There's no reason to clean up or anything, really. Look at that. We got just enough clearance, but there's no wiggle. Let's just visually check. So there we go. Our Česká zbrojovka 457 22 rimfire receiver now has beautiful threads to accept our new barrel. So we'll get you in there for some close-up shots and stuff, but you probably see it up there on that camera. But it's just that easy, right? Just get yourself a lathe, a couple decades worth of experience and knowledge of things like that, and you got yourself some threads. All jokes aside, guys, you see the level of attention to detail that I give this, the quality that you're going to get from it. So rest assured, you hire me to put yourself together a competition rig. This is what you're going to get out of it. So the receiver portion here is done. We may just do a little touch-up, clean up whatever work needs to be done. But like I said, I mean, our stub gauge goes in there. Our go gauge for this particular thread is bottoming right out. So that means our minor diameter is perfect. That means our thread depth is perfect. Everything's perfect. All right, let's just get a little close-up shot of these threads, just to show you how nice they looked. They came out very nice, shiny. Like I said, chatter-free. They're very smooth to the touch. Really doesn't even need any deburring, thanks to my threading insert there. Again, I wish I wouldn't have gotten so happy with the file on that thing, but you know, whatever. It is what it is. It's on the bottom, and it's not going to affect our torque shoulder, but I'm talking about this. You know, if you're just watching this, I used a file to check the hardness of the steel because there was rumors that this was coated with some super hard alloy like melanite or something, but that is not the case. At least with this particular action, this machine like butter. I mean, it's just beautiful. Absolutely no problems. Even with all those interrupted cuts in there, all the holes, we got beautiful threads there. So super happy. Hit us up, AccurateRiflesandRestorations.com. You'll find all of our information on our website and contact stuff. So yeah, just wanted to show you that up close. Česká zbrojovka 457 threaded receiver. All right, so there you have it. I hope I've demonstrated the level of care and attention to detail that I give each and every job that comes through the shop. All you 22 guys out there, rest assured, this is going to be the same level that you're going to get for each and every rifle that comes out of the shop. There's some debate on CNC versus manual machine. I'm a firm believer that manual machining, you can get just as good, if not better, oftentimes better results. Reason being is because it just boils down to hands-on. You know, you're not relying on a computer or robot or some sort of program to get the results that you're looking for. It's hands-on every step of the way. Granted, these two operations, but I think it really reflects in being able to dial in the action, or the receiver that is, just as straight and true as you saw me demonstrate how that's possible. No special chucks required, no fancy CNC equipment, with probably better results I truly believe that. You know, if I get into parts production down the road where I need to spit out 1,000 parts, then yeah, a CNC can come in handy for that kind of thing. I'm not arguing that point whatsoever. When it comes down to custom rifles and the highest level of precision and accuracy that you can attain, I firmly believe that doing it on a manual lathe such as this, very heavy, rigid, solid mass lathe, this is over 3,000 pounds here, so you know, I've been churning out really good rifles over the years. So anyway, just like I said, that's the level of care and detail that you're going to get here at Accurate Rifles and Restorations. For your next competition rig, you should highly consider us. My contact information is right there, so don't hesitate. I always got the phone on me. I'll answer every call that comes in. Be happy to talk to you and with you, and come up with a system that's going to be a winner for you.